Hi and welcome to question 9, 2014, paper 2, the Leave Cert Order level. This is section B we're on, and we're on the last question of the paper, so question 9. Now this question is worth 30 marks overall, so it's not that long a question. And the first part here, part A, is worth 10 marks and split on a C scale, so attempt 3, good work 7, and full correct answer 10. So what's happening? Let's read it, okay? Again, I suppose as always, I suggest pausing it, going through the question in the notes and seeing if you can figure out what to do, and watching the video just for any sections, whatever you were struggling on. At an activity centre, the zip line, which runs from B to D, so B as far as D, so that's the zip line, runs between two vertical poles, so the pole AB, the tall one, and a smaller pole DC, CD, on level ground as shown. The point E is on the ground, so here, and directly below the zip line. The length of AE is 12 meters. The length of BE is 14 meters. The length of CD is 1.95, and the length of EC there's 10. So all the information we're given is on the diagram. I would suggest here, before we do anything, let's see, is there anything I can add to the diagram that will help me, okay? Now I could use Pythagoras to find this thing here, because that would make a right angle. So right angle there, the right angle. You know, you're not told right angle, but by definition it has to be right angle. Okay. Then, if... Is there anything else I know? I'm given no actual angles. Right, so nothing I can think of I can find right now, other than that. So, part A, part 1, find the distance ED. So, this distance here. Okay. Correct to one decimal place. So I said already, okay, it'll be Pythagoras, because that's the right angle. So let's focus in on the answer here. So ED squared, that's the hypotenuse squared, equals the sum of the squares of the other two sides. Okay, I'm giving the other two sides 1.95 and 10, so it doesn't matter which I put them in. The way I have it labelled, it's 1.95 is DC and 10 is EC. Put them to the calculator, okay, and you end up with ED squared equals your answer. Bring the square root across, so the square across becomes square rooted. You end up with square root of 103, doing decimal. Put it through the calculator, I get 10.2. Now I'm sure I've rounded it already, okay, and the answer is for space reasons. And I've rounded one decimal place and I've my units included. Now it's very important with all these questions, if there's units involved, put the units in. If you're rounding, to round at the end of the question, not too early. You can lose a mark, and a mark, and a mark, and a mark. If you lose 6 or 7 marks over a paper, that's a percent, okay. Now, move on to part 2, so A part 2. Find the angle AEB, okay, correct nearest degree. So let's see what AEB is. AEB, so this angle here. Okay. Now you could draw it a separate thing, okay. Now that's a right angle triangle. I'm assuming it's focused on this triangle. If it's right angled, could be Pythagoras, but this is an angle we're looking for, so Pythagoras won't work. It'll either be sine, cos, or tan. Okay, so if that's the angle I'm focusing on, this is my opposite, so O for opposite. This 14 is my hypotenuse, the longest side, and 12 is the adjacent, so we'll put that A. So which formula, okay, do I have the adjacent and the hypotenuse in, and that would allow me, if I have that fraction, okay, to get the angle. So it should be cos, okay. So cos of an angle is no, that's wrong. That should be adjacent. I'll fix this after, okay? Apologies for that. So it's adjacent over hypotenuse, okay? So you should know the three formulas. They're in the maths tables, but the mnemonic I memorized in school was should old Harry catch a herring travelling off America. Sometimes you hear, oh hell, another hour of algebra. But whatever the mnemonic is, as long as you can write it down, you can access it easily. So the adjacent we said was 12, the hypotenuse was 14, so that's your fraction. What angle relates to that? Well, we need to look it up in the database. That database is stored in your calculator. You have the cos and the inverse cos databases. So you're looking for inverse cos of that fraction, or the decimal equivalent. And that my calculator retrieved that information as being 31 degrees. Now, I may have already rounded this here from the calculator, but that's to nearest degree, and the degree symbol is there, so units are there. Okay, so that's part 2. We're on 5 and 5 is 10 now, 20 marks left. So next thing then says B part 1, find DEB given that CED equals 11 degrees. let's go back. Okay, so CED is 11 degrees. We now know this was 31. Check that to make sure. 31. And I'm asked to find, I should remember, DEB. Okay, so DEB. So we have to find that angle there. Now, it should be straightforward enough. Okay, all the angles of a straight line equals 180. That's the theorem. You have 31 part of it, the other part of 11. You're looking for the middle bit. So if you take those away from 180, so put the answer up here. So 180, take away the 11, take away the 31, gives you an answer of 138 degrees. Okay, now part 2, hence or otherwise find the distance dB. So let's go back here and look at dB. So that we know was 138. I can put it in there legibly. We're looking for dB, so that's the question mark is there, that whole length there. Now you're focusing on this triangle, okay, which is a non-90 degree triangle. If you look at a non-90 degree triangle, the two formulas that should be most apparent are either the sine rule or the cosine rule. Okay. Now I also did work out this thing here was 10.2. So for the cosine rule to work, I need to know an angle and the two sides either side. Okay. If I do that, the cosine rule can be used to find the side opposite. Or if you have all three sides, you can use the cosine rule, if you rearrange it, to find the angle between two of the sides. Okay. So again, practice makes perfect. Cosine rule should be a method you have down. Same as the sine rule. It's just a matter of practicing it. And then recognizing which of the four formulas to use in any given problem. So we'll go to the problem itself here. I have the cosine rule written out. I put it in here in code here. You don't necessarily, you don't need to do this. I'm doing it there just to be very particular about it, okay? But you're looking for the side A. Okay, that's DB. Now remember it's squared, that can be a trick later on. And putting my numbers in, 14 was the length of EB, 10.2, you found that in part A, was the length of ED, minus 2 times EB and ED again, so 14 times 10.2, and cos of the angle in between is 138. Put to the calculator. Now don't forget here I have to square root whatever answer I get on this side. So whatever answer I get here, you square root that, okay, to get your final answer. And I put my units in. Okay, so that's part 2. Okay, that's for 10 and 5. 5, 5. Oh, sorry, for part 10, okay. So that's my 30 marks. So that's the end of that, okay. So I would suggest, in terms of practice for trigonometry, just to know the rules. The formulas are given to you. Just know the application for them and how to use the formulas. I see lots of mistakes here. People use the right formula, but they do just different things. I would suggest if you have the whole thing here, program the calculator, don't do it piecemeal. Okay. Anyway, so thanks so much. That's 2014 paper 2 finished. Any questions, always get back to me at shanetroy@cavininstitute.ie. Thank you.